In Module 3, Lesson 10, we're going to write and interpret inequality statements involving rational numbers. So we start in the opening exercises. The amount of money I have in my pocket is less than $5 but greater than $4. One possible value for the amount of money in my pocket could be $3.50. Nope, $4.50. Try that again. There are many numbers in between $4 and $5. I randomly selected $4.50. Then we're going to write an inequality statement. And that's a statement that has an greater than or equal than sign, a greater than or less than sign. And we're going to compare the possible value of the money to $4. So the money in my pocket, which is $4.50, is greater than $4. Greater than sign opens to the larger number. And then we're going to write an inequality statement comparing the possible value of the money in my pocket to $5. So $4.50 is less than $5. Now they ask us to then graph the answer from the opening exercise on the number line below, and also graph the points 4 and 5 on that number line. So on my number line, I located 4, and I counted by tenths to make sure that it would fit. 4, 4 and 1/10, 2, 3, 4, 4 and 5/10, and all the way to 5. I counted before I numbered to make sure that my scale of increasing by 1/10 at a time would fit on this particular number line. Then I graphed 4 and 5, and my number, which was 4 and 5/10, or $4.50. They ask us to write an inequality statement that shows the relationship among all three numbers. They ask us to write one inequality statement that shows the relationship among all three numbers. In other words, what we have to do is write a compound inequality so that we can include all three numbers rather than just two of them. And we can do this pretty easily. We can start to the left with our first value, which is 4, and then 4 we know is less than 4 and 5/10, and we know that 4 and 5/10 is less than 5. So our compound inequality looks like this. 4 is less than 4 and 5/10, which is less than 5. I'm going to show you the opposite of that as well, just so we know how we can write greatest to least. If I start to the right, then I would start with the number 5, and 5 is greater than 4 and 5/10. So we'll use the greater than sign. And then 4 and 5/10 is greater than 4, so again we'll use the greater than sign and 4. So if we are ordering them from least to greatest, we would write this way with the less than sign. And if we are writing from greatest to least, we would write them from right to left and would use the greater than sign. So in example 1, we're going to do the same thing. We're going to write one equality statement to show the relationship between these shoe sizes, 10 and 1/2, 8 and 9. From least to greatest, our smallest size would be 8. And 8 is less than 9, which is less than 10 and 1/2. From greatest to least, 10 and 1/2 is our greatest number, which is greater than 9, which is greater than 8. Example 2 is interpreting data and writing inequality statements from data, from information that we're being given. Mary is comparing the rainfall totals for May, June, and July. The data is in the table, and we'll need to fill in the blanks below to create the inequality statements that compare changes in total rainfall for each month. So we're going to take this column, the rightmost column of the table, and we're going to put these numbers in order. First of all, from least to greatest, and then from greatest to least. From least to greatest, the only negative number that we have is -1 4/10. So that would be the smallest number. Then moving on a number line, we'd be moving from left to right. The first number we would encounter on our way is 3/10, and then 5/10. But we needed to write these as a comparison. So I'll need to go back, and instead of putting a comma, I would need to put a less than sign, because -1 4/10 is less than 0 3/10. And 0 3/10 is less than 0 5/10. If you ever get a little confused by what you're doing, think about the numbers. Don't just try to remember some magic pill or potion that we came up with. Now, greatest to least, once you've written them from least to greatest, you can simply write them backwards. So take the whole thing, 0 5/10 is greater than 0 3/10, which is greater than -1 4/10. And they really are mirror images of each other. If you take a look at this statement and this statement, they should be really opposites of each other. Our question then is, in this case, does the greatest number indicate the greatest change in rainfall? Let's think it through. This says the change in total rainfall from last year to this year. So the change in total rainfall from last year to this year in inches includes when the amount of rainfall went down and when the amount of rainfall went up. But the biggest change is not the greatest number. Our greatest number was 5/10. But if rainfall went down 1 4/10, that's a lot bigger of a change than 5/10. Next, we'll look at exercises 5 through 8. Mark's favorite football team lost yards on 2 plays back to back. They lost 3 yards on the first play. They lost 1 yard on the second play. We need to write an inequality statement using integers to compare the forward progress made on each play. Forward progress is just a way to describe the result of the plays. The first play, they lost 3 yards. That's a -3. Then on the second play, they lost 1 yard. In comparison, the forward progress would be that -3 is less than -1. Because on the number line, -3 is further to the left. And they lost more yardage, so they are further behind when they lose 3 yards than they are when they lose 1 yard. Question 6. Sierra had to pay the school for 2 textbooks that she lost. One textbook costs $55 and the other costs $75. Her mother wrote 2 separate checks for each expense. Write 2 integers that represent the change to her mother's checking account balance. And then write an inequality statement that shows that relationship. Well, because her mother had to write checks, those are both negative numbers. Negative 55 and negative 75. An inequality statement to compare them then could be negative 55 is greater than negative 75, because on the number line, remember, if you start at 0 and you start counting negative 1, negative 2, negative 3, negative 4, negative 5, and continuing, you would hit negative 55 first, and then negative 75 would be further to the left. Question 7. Jason ordered the numbers negative 70, negative 18, and negative 18 and 5/10 from least to greatest by writing the following statement. Negative 18 is less than negative 18 and 5/10, which is less than negative 70. Is this a true statement? Explain. So if we were to write a number line with these numbers, they are all negative numbers. So if we consider 0 being here on our number line, and counting backwards, negative 1, negative 2, negative 3, negative 4, negative 5, and continuing, first number we would encounter is negative 18, which means that that number is furthest to the right. And that makes negative 18 greater than negative 18 and 5/10, which is much greater than negative 70. So Jason is incorrect. And finally, you're asked to write a real-world situation that's represented by the inequality negative 19 is less than 40, and explain the position of the numbers on a number line in the same way that we have been answering these questions all along.